Dear friends, today we start with lecture 7 of Math 303. As I said earlier in the previous lecture, what is sequence? Sequence is a function whose domain is n. What is series? Sum of terms of sequence is series. Now I define partial sum z1 plus z2 up to z capital N, and we denote it by capital S and capital N. And this is sigma Zn, n running from 1 to capital N. We say that Sn converges to S as n tends to infinity, where S equal to sigma Zn, n is running from 1 to infinity. This is a symbol. Just to recall the definitions of the sum of terms of sequence, that is series, as you learned in the previous years. Now I start with 86. Zn is a complex number xn plus iyn, and x is equal to x plus iy. Sigma Zn is as double implies sigma xn equal to x and sigma yn equal to y. That I wanted to prove. And the proof is very simple. Sigma Zn equal to S converges. So I start with one part, and now the remaining part is in double implies. This double implies Sn converges to S as in the definition. This double implies Xn converges to X and Yn converges to Y. Now what is it? Xn is sigma Xn, or I say Xk, k is running from 1 to n, and Yn is sigma Yk, k is running from 1 to n. Obvious notations are there. This double implies sigma small xn is equal to x, or you may write it from n is running from 1 to infinity, or don't write that. If you are not writing that, it means that it is running from initial point to the last point, means up to infinity. And sigma yn equal to y. N is running from 1 to infinity. And if you this converges, and if you go the back way, you will prove the reverse one. So in both the way, this is true. But whenever you may ask the same question in exam, you have to go through as per my notes. Clear? Okay. Here we have Zn is equal to sigma xn plus I sigma y. Obviously n is running from 1 to infinity. This is x plus iy, and this is s. Now the central idea of this topic is that if this is convergent, this is convergent, this is convergent. Both these are xn is real number. This yn is real number. This is convergent. This means that xn converges to 0. This means that yn converges to 0 as n tends to infinity. And therefore, Zn equal to xn plus iyn. This is tends to 0 plus I into 0, and therefore it converges to 0 as and tends to inherit it. Means Zn equal to Xn plus Iyn, 0 plus I into 0 equal to 0. And therefore, Zn converges to 0 as n term tends to infinitive. So this is corollary 87. Corollary means it's a small theorem which is depends on the some theorem. Lemma is a small theorem. Corollary is a small theorem, but it depends on some theorem, and in mathematics we call it corollary. Now, in series chapter, we have defined absolute convergence. Whenever we define absolute convergence, if the modulus of Zn, means the modulus of that number converges, means this is equal to sigma square root of xn square yn square. As I mentioned in my note, this Zn is a complex number, but this whole is a real number. This converges, then we say that sigma Zn is absolute convergent. This is definition 89. But you know that modulus of xn square plus yn square, modulus of yn square root of xn square plus yn square. If this is convergent, sigma xn modulus xn convergent, sigma modulus yn convergent. That means that both these are convergent, absolute convergent, and due to that sigma xn are convergent. And that is corollary 19. And we are in the conclusion of the unit 1. At this juncture, after 90, it's a small theory. Okay. S equal to sigma z raised to n. N is running from 0 to infinity, so it is equal to 1 plus z square, and all other terms. And obviously you know that this sum is equal to 1 upon 1 minus z. Sn is 1 plus z square plus z raised to n minus 1. So this is equal to 1 minus z raised to n minus 1. Z raised to n upon 1 minus z. Obviously, whenever we are taking this, it is confirmed that modulus z is less than 1. We have always that in our mind. So, we define one term rho n z equal to s minus sn. So, this is equal to 1 upon 1 minus z minus 1 minus z raised to n upon 1 minus z. So obviously this is equal to z raised to n upon 1 minus z. So if we take the mod of this and mod of this, so whenever it is required in future, just I am marking it here. Okay, with this unit 1 is over, and immediately we start with unit 2. Okay, we start with unit 2. We call this unit as a CR equation, Cauchy-Riemann equation. To mathematicians who have done lots of work in mathematics, but we are restricted to our syllabus. And without taking any further information about Cauchy and Riemann, I start with the second unit. F is from H to C. Obviously, S is subset of complex plane. And if we define fz equal to omega or say w, means z is a complex number, w is a complex number. How it is? I just writing it here. In the second one, f is from c minus 0 to c, and we define fz equal to 1 upon z. That means that it is always defined but only for non-zero values. What is that? That is x plus iy. Now I want to simplify this. And keep in mind that as z is x plus iy, omega is u plus iv. Whenever it is required, I will use it. So this is value of, this is omega for us, and therefore this is value of u plus iv. Now I multiplied and divide by x minus iy. So what it will be? X minus iy and x plus iy, x minus iy. If you multiply both these terms, what you will have? X square minus I square y square. But what is I square? That is minus 1. So this value is x square plus I square, x square plus y square. Now split them. So these are values of u and v. U is x upon x square plus y square, and v equal to minus y upon x square plus y square. I think it is enough for this function, but we can go some few steps more in the same context. If I say u square plus v square, what it will be? X square plus y square square plus y square, x square plus y square square. So I think if you adding both these terms, so this is equal to 1 upon x square plus y square. So u square plus v square is this. So as I am here right now, you have values of x and y. Therefore, now if you make the object to the x, what is x? U upon u square plus v square. What is y? Minus v upon u square plus v square. Just by using this fact, u square plus v square is this. I always emphasize that keep your pen and paper ready. Whenever I'm writing on the board, you should write at a time. whenever I am writing. And keep practicing all these things. If my lecture is of few minutes, you have to practicing lot of times. If you are writing it, you will find it very comfortable. Okay, let's start with something more. Okay. Now at this juncture, we have learned definition of limit at school level. Then in first year, then in second year, then in third first. Each and every time you have definition of limit and continuity and differentiability. And it is nothing special there. It is again here in third year. And you will find the same definition in master level. So just recall that what is definition of limit of function. For given epsilon positive, there is delta positive such that for given epsilon positive, there is delta positive such that 0 less than z minus z0 less than delta implies fz minus omega 0 less than epsilon. And this is a definition of a limit of function f at point z0. And the notation is, what is notation? Limit z tends to z0, fz equal to omega 0. This is notation of limit of function f at point z0, and the limit is omega 0. Now, at the same time, I would like to define continuity of a function. The statement is the same. For given epsilon positive, there is delta positive such that z minus z0 less than delta fz minus fz0, this is less than epsilon. And this is definition of continuity, and the notation is limit z tends to z0, fz is fz0. This is continuity, and this is limit. If you see one time, you will find both these definitions are very similar, and hardly students can understand what is the difference there. But if you learn it from first year, from schooling, then first year and then second year, there are three differences. Which are they? This is limit, and this is continuity. Which are the differences? The first difference is that z is not z0 because 0 less than z minus z0. What is second difference? Here it is omega 0 and there it is fz0. And the third difference, due to that, this is second difference. And the third difference is not visible. Can you imagine what is that third difference? I think as a student you can't. But the third difference is that z0 may or may not be belongs to the domain of f in limit. Listen carefully. z0 may or may not be in the domain of f whenever we are talking about limit. But z0 is must in the domain whenever we are talking about continuity. This is a third difference. Okay, with this I conclude my lecture. But keep in mind you have to write this definition so many times from my notes. And make it that much easy for yourself by writing, by understanding. Whenever I am talking about the differences of the limit and continuity, you should have in your mind all the notions which I have given to you. Okay, thank you very much.